fundamental theorem of difference calculus. What it says, if fx be a polynomial of degree n, then the nth order difference is constant and n plus 1th order difference vanishes. Means if we consider a polynomial of degree n, for example, if we consider fx equal to a0 x to the power n plus a1 x to the power n minus 1 plus dot 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 a n minus 1 x plus a n, then and if we calculate delta to the power n fx, that will be equal to constant, and that value, actually this value will be equal to a0 n factorial h to the power n. Also, delta to the power n plus 1 fx, this value will be equal to 0. This is the fundamental theorem of difference calculus. Next we go to shift operator. The shift operator is denoted by E and defined as E of fx equal to f of x plus h, where h is the space length. We also can say that e to the power n fx can be written as f of x plus nh, and also the inverse shift operator is denoted by E inverse and defined as E inverse fx equal to f of x minus h. Now we see the relation between shift and forward difference operator. For forward difference operator, delta, we know that delta of fx equal to f of x plus h minus fx. Now we already see that f of x plus h can be written as e of fx minus fx. So which will be actually e minus 1 of fx. So therefore delta equal to e minus 1. This is the relation between forward and shift operator. You can solve some problems now. First problem. Estimate the missing term in the following table. X and corresponding fx values are given in this table. X equal to 0, 1, 2, 3 and 4, and corresponding fx values are 1, 3, 9, and you have to find this value corresponding to x equal to 3 and last value is 81. Now to solve this problem, we have to identify corresponding to how many arguments the values of fx are given. For this problem, we see that corresponding to 4 arguments, the values of fx are given. So we can assume a polynomial of degree 3 whose corresponding values are given in this table. So by fundamental theorem of difference calculus, we can write delta to the power 4 fx equal to 0. As we know, in the fundamental theorem of difference calculus, if fx be a polynomial of degree n, then delta to the power n plus 1 fx equal to 0. So using this concept, we can write, since fx is a polynomial of degree 3, we can write delta to the power 4 fx equal to 0. And also we know that delta equal to e minus 1. Now putting this relation in this equation, we get e minus 1 whole to the power 4 fx equal to 0. Now we expand this one binomially. So if we expand this one binomially, we get e to the power 4 minus 4 eq plus 6 e square minus 4e plus 1 into fx equal to 0. Now we also know that e of fx equal to f of x plus h. Also we know that e to the power n fx equal to f of x plus nh. So using this relation e to the power n fx equal to f of x plus nh, we can write e to the power 4 fx equal to f of x plus 4h, and eq fx equal to f of x plus 3h. Similarly, e square fx equal to f of x plus 2h, and e of fx equal to x plus h, and lastly 1 into fx equal to fx equal to 0. Now for this problem, we already see that h equal to 1. So putting h equal to 1 in this relation, we get f of x plus 4 minus 4f of x plus 3 plus 6f of x plus 2 minus 4 into f of x plus 1 and plus fx equal to 0. Now, in this problem, the initial value of x equal to 0. So, we putting x equal to 0 in equation 1, we get f of 4 minus 4f of 3 plus 6f of 2 minus 4f of 1 plus f of 0 equal to 0. Now we put the values of f of 4, f of 3 here. F of 3 you have to calculate, f of 2, f of 1 and f of 0 from the table. So f of 4 equal to 81, we put this one. F of 3 which you have to calculate, f of 2 equal to 9 and f of 1 equal to 3 and f of 0 equal to 1. So if you simplify this relation, we get the values of fx, means where you have to find the value, here x equal to 3. So at this point you have to find the value. So f of 3 equal to 31. Problem. Estimate the missing term from the following table. X and corresponding fx values are given in this table. X equal to 2, 4, 6, 8 and 10, and corresponding values of fx are 5.6, 8.6, 13.9, and you have to calculate this value, and 35.6. Now to solve this problem as previous one, first of all you have to find corresponding to how many arguments the values of fx are given. So in this problem also, corresponding to 4 arguments the values of fx are given. So we can assume fx to be a polynomial of degree 3 such that delta to the power 4 fx equal to 0. Now, from the fundamental theorem of difference calculus we already discussed in previous problem. So using this concept we can write delta to the power 4 fx equal to 0. Now as similar one, we know delta equal to e minus 1. So if we put delta equal to e minus 1, we can write e minus 1 whole to the power 4 fx equal to 0. So similarly, we expand this one binomially. It will be e to the power 4 minus 4 eq plus 6 square, then minus 4e plus 1 into fx equal to 0. So as previous one, we can write e to the power 4 fx, e to the power 4 fx as, or f of x plus 4h minus 4 f of x plus 3h plus 6 f of x plus 2h minus 4 f of x plus h plus fx equal to 0. Now for this problem, h equal to 2. So if we put h equal to 2 in this relation, we get f of x plus 8 minus 4 f of x plus 6 plus 6 f of x plus 4 minus 4 f of x plus 2 plus fx equal to 0. Now you have to identify what is the initial value of this problem, means the initial value of x. For this problem, initial value of x equal to 2. So we put x equal to 2 in this relation. Now if we put x equal to 2 in this relation, we get f of 10 minus 4f of 8 plus 6f of 6 minus 4f of 4 plus f of 2 equal to 0. Now for this problem we have to find f of 8. Now we put this value of f of 10, f of 6, f of 4 and f of 2 from the given table. So if you put the values, we get f of 10 equal to 35.6 minus 4 f of 8, which you have to calculate, plus 6 f of 6 equal to 13.9 minus 4 f of 4 is 8.6 plus, and f of 2 equal to 5.6 equal to 0. Now if you simplify this relation, we get the values of f of 8. So if you simplify, f of 8 will be equal to 22.55. This will be the answer. Next problem. Estimate the missing term in the following table. X values and corresponding fx values are given in this table. X equal to 0, 1, 2, 3, 4 and 5. Corresponding fx values are 0, not given, you have to find that value, 8, 15 and also you have to find this value, and last value is 35. Now here total number of arguments is 6, but corresponding to 4 arguments the values of fx are given. So you have to find the values of fx at x equal to 1. Also you have to find the value of fx at x equal to 4. Since corresponding to 4 arguments the value of fx is given, so as previous one we can consider a polynomial fx whose degree equal to 3, and using the previous formula we can write delta to the power 4 fx equal to 0. Also we know that delta equal to e minus 1, so if you put e minus 1, this equation becomes e minus 1 whole to the power 4 fx equal to 0. Using binomial expansion we can write this one as e to the power 4 minus 4 eq plus 6 e square minus 4 e plus 1 into fx equal to 0. So using this formula, e to the power n fx equal to f of x plus nh, we can write this one as f of x plus 4h minus 4 into f of x plus 3h plus 6 f of x plus 2h minus 4 f of x plus h plus fx equal to 0. Now in this problem also the value of h equal to 1. So if you put h equal to 1 in this relation, we get f of x plus 4 minus 4 f of x plus 3 plus 6 f of x plus 2 minus 4 f of x plus 1 plus fx equal to 0. Now here you have to find the two values, that is f of 1, also you have to find the value of x, f of 4. So to find these two values, first of all we put x equal to 0 in this relation. If you consider this is the relation number 1, so if you put x equal to 0 in relation number 1, so if you put x equal to 0, this relation becomes, or we can write f of 4 minus 4 f of 3 plus 6 f of 2 minus 4 f of 1 plus f of 0 equal to 0. Now we put this value from the above table. So if you put, you have to find the value of f of 4 minus 4 into 15 plus 6 into 8 minus 4 f of 1 which you have to find, and f of 0 equal to 0. So this value equal to 0. Now if you simplify, we get this equation as f of 4 minus 4 f of 1 equal to 12. Consider this is our equation number 2. Equation number 2. Next, we put our next argument, that is x equal to 1. So if you put x equal to 1, we get from the relation number 1 or equation number 1, f of 5 minus 4 f of 4 plus 6 f of 3 minus 4 f of 2 plus f of 1 equal to 0. Now from the above table, we put these values. So if you put this value f of 5 equal to 35 minus 4 f of 4 which you have to find plus 6 into 15 minus 4 into 8 plus f of 1 which you have to find. So if you simplify this one, we get the equation as 4 f4 minus f of 1 equal to 93. So consider this is our equation number 3. Now if we solve the equation number 2 and 3, solving equation 2 and 3, we get 2 and 3, we get f of 1 which will be equal to 3 and f of 4 which will be equal to 24. So these are the answers.